Welcome to another episode of Terry's Notes. And today we're going to be looking at the June 2015 paper, question 10. Alright, so part A, we have a diagram. The diagram below, not drawn to scale, shows a vertical tower BT. So this is the vertical tower here, from here to here, with a flagpole TP. So this is a flagpole on top of the tower. A point R is on the same horizontal ground as B. So this is R here, such that RB is 60 meters. So this here represents 60 meters, right? The angles of elevation of T and P from R is 35 and 42 respectively. So the angle of elevation of T from R, that is this angle here, which is, so this is 35 degrees. So that's this angle here. And the angle of elevation of P from R is 42. So this bigger angle here represents 42 degrees, right? So label on the diagram the distance 60. So we've done that. We've labeled the angles 35 and 42, and any right angles. Well, this will be a right angle here. Okay. Now they said calculate the length of the flagpole. Right. So we want to get this distance here. So the length of the flagpole is really PT. Right. Now just by looking at this here, to get PT, we just need to find PB, which is from here to here, right? So this is PB here, this distance here, and this is TB, so minus TB, right? So that is how we're going to find the length of the flagpole PT. So so all we need to do is, let's look at the first triangle here, which is TB and R, and we can find BT or TB, right? So we have an angle, we have adjacent, and we want to find opposite. So therefore, remember the rules that I taught you before: SOCH, so, ka, tua. Now this is a right angle triangle, therefore we can use either sine, cosine, or tangent, right? But to figure out which one we have to use, we look at the information that is given. So we are given an angle, we have adjacent, and we want to find opposite. So we have adjacent and opposite. So therefore we are going to be using tangent, right? So let's start off by writing tan theta is equal to opposite over adjacent, right? So tan 35 is equal to opposite, which is BT or TB, doesn't matter, over adjacent, which is 60. Alright, so remember, when we have tan 35, we could write that as tan 35 over 1, and we just cross multiply. So we get TB is equal to 60 multiplied by tan 35 degrees. So therefore TB is equal to, well, at this point you use your calculator, so 60 multiplied by tan 35, and that gives me 42.0. Now they want the final answer to the nearest meter, so I will put 42.0 meters. So that is TB. So let's work out PB now, which is a longer distance. And again, we have an angle which is 42. We have adjacent, which is 60, and we want to find the opposite. So we write it as tan theta equal opposite over adjacent again. So tan 42 is equal to opposite, which is PB all over adjacent, which is 60 again. Alright, so we can write this tan 42 as tan 42 over 1, and we cross multiply. So PB is equal to 60 multiplied by tan 42. So therefore PB is equal to, and we use our calculator again, so 60 multiplied by tan 42, and that gives me 54.0. So this is 54.0 meters. Alright, so we can find the length of the flagpole PT now, which is PB, which is 54.0 minus TB, which is 42.0, and this will give me, so 54 minus 42, and that gives me 12 meters. Alright, so this pen is giving some trouble, so 12 meters. Right, so that is the length of the flagpole. Okay, so let's do part B of the question. This is the diagram below, not drawn to scale, shows the relative positions of three fishing boats, K, L, and M. L is on a bearing of 40 degrees from K, and M is due south of L. And LM is 120 kilometers, and KL is 80 kilometers. On the diagram, show the bearing of 40 degrees. Now they said L is on a bearing of 40 degrees from K. Alright, so the bearing, how you read this is 40 degrees from K. So we are starting at K, we draw our north line here, so therefore this angle here represents 40 degrees, right? So because this is the line KL, so the bearing of L from K is 40 degrees, right? Also they said that M is due south of L. What does that mean? That means that if this is the point L, then M is directly below it, which means that this north line here is parallel to this line here, right? Which we might need that piece of information. So they said draw the bearing of 40 degrees, and then they want to calculate the measure of KLM. KLM is this angle here. So we have two parallel lines here, which is NK and LM. So therefore, if this is 40 degrees, then this has to be 40 degrees as well. They are alternate angles, right? So this here is 40 degrees. And then they want to calculate the length to the nearest kilometer of KM, right? So this is K and this is M here. So we have, now this is not a right angle triangle, so we either have to use the sine rule or the cosine rule. We use the cosine rule if we have three sides, no angles, or we have two sides and an angle that is between them. In this case, we have 80 kilometers and 120 kilometers, and we have the angle of 40 degrees between them. So therefore, I have to use the cosine rule to solve for Km. Right? So let's set up the sine rule, the cosine rule first, which is c squared is equal to a squared plus b squared minus 2ab cos a. Alright, now c is a length that is opposite the angle, so this is the length we are talking about here, which is km. So this is km squared is equal to a squared, which is 80 squared plus 120 squared minus 2 multiplied by 80 by 120 cos 40. Right? So therefore km squared is equal to, at this point what you should do is to work out the individual terms. So 80 squared gives me 6,400. So this is 6,400 plus 120 squared. This gives me 14,400. 14,400 minus, and we should work out the entire bracket, right? So this will be 2 multiplied by 8t multiplied by 120 multiplied by cos 40, and that gives me 14,000. So this is 14,708. Therefore km squared is equal to, right, so let's work this out. So this is 6,400 plus 14,400 minus 14,708, and that gives me 6,092. Therefore km is equal to square root of 6,092. So therefore km is equal to 78, right? Because I wanted to the nearest kilometer, so we'll put this as 78 kilometers. So this is 78 km. Now let me double check this. All right, it's very easy to make a mistake here. 8 squared plus 120 squared minus 2 by 80 by 120 by right, so the answer is 78 kilometers. Right, so that's the answer for here. Right, now we want the angle LKM. LKM is this angle here, right? So at this point we can use the sine rule, because we have 40 degrees and we have the length opposite, and we want to get this angle here, which is LKM. So we can use the sine rule. So we say A over sine A is equal to B over sine B. So let's use A as 120 over sine LKM, which is what we want to find, which is equal to B, which will be 78 over sine 40 degrees, right? So therefore sine LKM is equal to, we're just going to cross multiply here, so we'll end up with 120 multiplied by sine 40 degrees over 78. So sine LKM is equal to, and we work that out, so this is 120 multiplied by sine 40 divided by 78, and that gives me 0.9. So this is 0.989. So therefore LKM is sine inverse of 0.989. Therefore LKM is equal to second function sine, and that gives me 81 degrees if we're going to the nearest. So this is 81 degrees, right? Let me just double check that and make sure there's no mistakes. There are no mistakes. So sine 40 multiplied by 120 divided by 78, second function sine. Right, so we get 81 degrees. Right, so that's the answer for this part. And then they said calculate the bearing of M from K. So we're starting at the point K, and this is M on the side. So we want this whole angle here. Right, so we know this is 40 degrees. This one here is 40 degrees. And we just worked out this one. We got 81 degrees. So therefore it will be 40 degrees plus 81 degrees, and this will give me 121 degrees. So therefore the bearing of M from K is 121 degrees. Okay.